Hello everyone, in this video we'll be going over uh, what is particularly new about the BlackFly personal flying machine. There are a lot of prototypes that gain a lot of publicity, and it can be hard to tell which of these new personal flying machines would be practical or have a chance of becoming widespread. So I hope to bring to light some of the details, the technical details of the novel aspects of these new machines, so everyone can sort of better assess uh, what's likely to be practical. So here's a picture of the BlackFly in flight. There's a really awesome demo video by the BlackFly company, opener, on their YouTube channel. So check that out if you haven't. So just as an introduction, the company and the machine was invented by Marcus Leng. According to his website, he's actually responsible for the first manned flight in a fixed-wing, all-electric VTOL aircraft. So that's a pretty lofty title, and all the patents, you'll see the assignee of the patents of his patents to be Skycar Incorporated. That was actually the old name of his company. In 2014, Larry Page acquired or heavily invested in Skycar, and the name changed to Opener. So this is not an exhaustive, I mean, it's just one aircraft, but there may be others out there, but I found it kind of interesting that there's at least one out there that looks pretty similar. As you can see, there's a tandem wing here, two wings and propellers arranged similarly. But the first introduction of this Vahana, I think by Airbus or some huge company, appeared in 2016. Yeah, so I tend to think that maybe, well, Opener's been pretty secret up until recently, so maybe there wasn't sort of some influence, but definitely Marcus Leng was one of the first, if not the first, to have, like an all-electric tandem wing VTOL aircraft. So you can see in the records the first patent action for the BlackFly aircraft was in 2012. So I think, I would guess, I mean, I don't know for sure, I would guess that the aircraft configuration of Marcus Leng's aircraft is the first of its kind, yeah, so he's like the original sort of inventor of the whole aircraft concept. So the having tandem wings is not a new concept. In fact, one of the first, like most viable, I mean, it didn't actually fly, but it came close to it at least, relatively speaking. Back in the 1900s, the Langley Aerodrome of Samuel Langley. That aircraft, although it crashed in the he made a successful steam-powered unmanned prototype, but his manned version, which is significantly larger and suffered from structural failures, was not successful. But it was a tandem wing aircraft. So yeah, as you can see over the years, this is just an example list I pulled off Wikipedia. You can see it comes up every, pretty consistently throughout the last 100 years or so. Probably the, I guess, most widely recognized modern example would be the Rutan Quickie, made by Burt Rutan, who's had success in making the Spaceship One, I believe, and other Canard aircraft. So yeah, let's get into the patents. This is what we'll look at for assessing the novel components of the BlackFly aircraft. So the patents are detailed documentation of all the features of filed by Marcus Leng. And so it kind of gives us a clear picture of what is new and how it differentiates from all the other attempts, flying machine attempts. So there are two notable patents that I found. One is for the aircraft configuration, and the other is for the electric motor. The electric motor is still in application stage. It was filed in 2014. And as you can see, like, to become an actual patent, it takes a while. So the aircraft patent has already been published in 2018, but it took 6 years to do so. So we might have to wait a year or two for the electric motor patent to come out. But it still contains sort of the details we would need, some interesting details. So let's go over the aircraft patent first. So I looked through the summary section and picked out some of the most interesting points here. You can see I'm skipping around 4, 34, you know. There's a lot of points there, but I sort of tried to reduce it to the most interesting ones. And so the first one here, we see that the washer from the propellers is directed along the surface of the wing to provide lift and forward thrust to the vehicle. So it looks like they are relying on some lift augmentation on the wings due to the propeller downwash. That is, you know, relatively unusual. And taken to the extreme, you can see, I think, the famous NASA distributed lift propulsion experimental plane. I forget the name of it, but it's where you have a bunch of tightly spaced small electric fans all along the length of the wing. So it's a valid concept. It does augment the lift of the wing through, I guess, delaying stall would be one important aspect of it. Or at least increasing the maximum lift coefficient. So the next point, this is an interesting, you know, construction detail. So it's a really traditional wing construction. You have a rigid foam inside with a outside skin of, you know, really strong rigid material. In this case, carbon fiber, some kind of carbon fiber composite. The next point. So this kind of clues us into the capability of Marcus Leng's motors. So actually, he has an innovation related to the brushless motor that I will get into later. But there's not much performance information available that I could find, at least. And so I thought this was interesting because it's like one of the only like actual quantitative data I could find. It's a little meaningless because you don't know, there wasn't much details on the size and weight of the motor and, you know, current limit, voltage or whatever. So yeah, anyways, the next point talks about the inclination of the propellers relative to the, I guess, the chord plane, the wing chord plane. So they're slightly angled upwards 6 degrees in the preferred implementation. Yeah, so I just thought that was an interesting fact. So this angle might have been refined by Marcus Leng in order to improve the the lift augmentation aspect of having the wing and propeller combination. Although that's not explicitly stated, it's a possibility that's the case. And the final point is sort of electronic control of the aircraft um, through windmill braking. So this is when the propellers are not being actively powered and they're and wind is blowing, through the propellers and spinning the propellers, converting the wind energy into the rotational energy of the propellers. And I guess this could be interesting. I don't know if it's already been proposed in a previous patent application, but in prior art, but it's sort of an interesting, like, I guess, safety feature. So even in a full power out situation, just merely by falling, you could have the electronic controller modulating the speeds of the windmill braking action in order to affect forces and moments to control the aircraft during descent. All right, and now this is what I picked out from the claims section of the patent that I thought highlighted the novel aspects, finally. So yeah, I mean, the previous slide showed some of this, but I think this is sort of, as far as the aircraft configuration, this is sort of the stuff that most differentiates the BlackFly aircraft from other ultralight vehicles. So obviously we have the second claim, multiple wings. The third and fourth claim kind of are related, and it's that the BlackFly aircraft can kind of rock on the fuselage and therefore have multiple landing angles and flexible takeoff orientations. So if you need to pitch down if you think of a typical aircraft, it's a typical ultralight aircraft. It's kind of, you can't really control when you're on the ground, you can't really control the angle of attack of the aircraft. But in the BlackFly, it kind of rocks on its fuselage. So just by applying power to one of the, to any of the propellers, you can sort of control your orientation while you're landed, just by rocking on the fuselage. And you can notice claim 3 says two. I've summarized it as 2 landing angles. That's what it says in the patent. But I believe more recent iterations of the BlackFly has a curved fuselage underbody where, obviously you can have infinitely many, technically speaking, landing angles. But yeah, I think that's a really novel feature. It can be really actually advantageous. I certainly haven't seen that in other aircraft, or at least can't think of any off the top of my head. So the aircraft configuration isn't really that innovative, and I think the real innovation comes from his motor patent, Marcus Leng's motor patent. So it hasn't been published as a patent yet. So if you want to find it, you have to go to the USPTO application search database rather than the patent search database. And it basically boils down to the flux ring around the motor. So brushless motors usually have a flux ring around, it's the outermost ring on the motor. That's the part that's directly connected to the magnets, and it's meant to sort of contain the magnetic field and amplify the magnetic field from the permanent magnets on the rotor on the outside, and as well as the generated magnetic field from the stator, from the wire coils. So when you enhance the magnetic field, you get more torque, you get better efficiency. So it's a pretty important part of the motor. So what he's done is, instead of having what I would assume to be the common implementation is a solid metal ring for the flux ring, he instead has a bunch of metal sheets, concentric sheets, that are split circumferentially and also layered concentrically. And these sheets are insulated from each other. So what you end up with is concentric layers of sheets that are much less electrically conductive, but pretty much as magnetically conductive as a solid metal ring. And what that means is that, well, according to the patent, is that, as you can see in the section 41 down here, this reduces the size of the eddy currents in the rotors, which would be the current running around in the the flux ring, and reduce the waste heat generated by this eddy current. So reducing heat is really important, because as you increase heat, as temperature increases, the efficiency or resistance goes up, so the efficiency of the motor goes down. So it's kind of so you need to apply more power in order, if to get the same output. So it's kind of a vicious cycle in a way. So less heat is very important and very beneficial for overall efficiency and maximum power even. I mean, that's one of the huge advantages of brushless motors over brushed motors, is the heat problem. So here's a diagram so I've highlighted the red as the stator, so you can see where the divide is. And as I've explained before, you can see there's a bunch of concentric rings, layers, that are split here. So you can see number 2 indication, you can see that it's split there, and there would be some insulating material. So you can see splits all along the concentric, all along each layer. So if you can imagine like an eddy current running through this whole through the ring, if it were solid, you can see how this eddy current could be stopped by splitting the rings circumferentially and having layers of these rings instead of one solid ring. So this appears to be the mechanism by which the eddy current is reduced, and therefore the heat. So it sounds like a really good idea. It sounds like a really good idea that could have huge benefits, but I couldn't find any actually data, like quantitative data of performance comparisons or anything like that compared to like a normal flux ring. So I'm not sure if there's any trade-offs with this. So maybe it's possible. I mean, I'm not sure, but it's possible that this configuration, Marcus Leng's new flux ring, could reduce the magnetic containment somehow. But there's no data, demonstrating this, at least that I could find. But it certainly sounds like a good idea, and I would bet that it does give an improvement. How much? I'm not sure. So, in conclusion, the core innovation of Marcus Leng's aircraft is the flux ring, is his flux ring design, and basically the efficiency of his brushless motors. The aircraft configuration is unique, but it's less of a innovation, but it certainly can be practical and potentially useful. I hope I've been able to break this down in technical terms and summarize it so that you can see what exactly is great about this aircraft and what is new about it. If I made any mistakes, or if you guys have more data, I mean, I'd love to see performance data on the Flex Ring. Please leave comments, and thanks for watching.